Okay, so this first problem we're going to do is under the big umbrella category of gravimetric analysis. And in these types of problems, you figure out how much of a substance you have by precipitating it out and turning it into a part of another compound. And then from that, you work backwards and figure out how much you originally had in the original sample. For example, let's say you had lead in your water and you wanted to know how much lead you have in your drinking water. Well, you would need to find something that would precipitate the lead out and turn it into an insoluble compound, and then figure out what's the percent lead in that compound, and then that's the amount of lead. And once you figure that out, then that's the amount of lead that was originally in your sample of water. In this problem over here, we're going to do that for a silver compound. So there's this silver in solution. You need to precipitate it out, and what you want to do is then calculate how much silver precipitated out, and that silver was what originally started off in that original compound. Hopefully it'll be clearer once I start going through the steps. Like I said, this process is called gravimetric analysis, determining the amount of a substance by gravimetric analysis. So our scenario, a soluble silver compound was analyzed for percent silver. How did we do that? By adding sodium chloride to precipitate out the silver. Why would the sodium chloride precipitate out the silver? Because you remember your solubility rules. Silver plus chloride forms silver chloride, an insoluble precipitate. Remember how chlorides are all soluble unless they're hooked up to silver, mercury, lead? Okay, so precipitate the silver ion. If originally you had 1.583 grams of silver compound, that was the original soluble compound. This one, when you added the sodium chloride, an excess of sodium chloride, you ended up with 1.788 grams of silver chloride. We don't know what the original compound was. We just know the mass of the original compound, and we know that it was soluble. Okay? Now, it could have been like a silver nitrate. It could have been anything, but something that is soluble. But now we collected 1.788 grams of silver chloride. Okay, so all the silver that is in this silver chloride originated from this silver compound up here. Okay, so what we have to do is figure out how much silver do we have in the silver chloride. Do you remember the percent composition problems where we had to do percent silver in silver chloride or percent anything in another compound? So we do a percent composition problem. We figure out what is the percent silver in silver chloride. Okay, that's the first step. Do you remember how we did that? All you do is you get the mass of the silver from the periodic table divided by the total mass of the silver chloride times 100, and that's your percent silver in any silver chloride compound. So we crunch the numbers. We look up the molar mass of silver. So silver is 107 point, I'll just go with what the periodic table is telling me, 87 grams per mole. This is the silver. And then I need to add this to the chloride, to the chlorine, which is 35.5. So that's 143.37, 43.7, and then times 100. That's your percent composition of silver in silver chloride. And you find that it is 75.2%. 75.2%. Okay, that's how much silver is in silver chloride, in any silver chloride compound. All right, so what are we going to do with this number? Well, we collected 1.788 grams of silver chloride. So 75.2% of that is silver. So we're going to go 1.788 times 0.752 is equal to We do the math. And where's my calculator? It is 1.345. 1.345. Probably too many sig figs, but that's okay. Grams of silver. All right, so we collected in our sample 1.345 grams of silver. This is how much was originally in the silver compound. So the original silver compound was 1.583 grams. Of those 1.583 grams, 1.345 grams are silver. So their question is, what is the percent silver in the original compound? You'd go percent silver in original compound would be 1.345 grams of silver, and then you put it over 1.583. Don't mix the two, because this is the precipitate, this is the silver chloride, this is the original silver compound. Grams of silver compound, Ag compound, some unknown compound, times 100. So do the math, and you end up with about 85%. It's like 84.98, et cetera. So yeah, I would say if you want to go with only 3 sig figs, which I probably should have done back over here, I could say 85% or 85 or 84.9 some percent. Okay, so both are okay. All right, so that is an example of gravimetric analysis. You will be using percent composition. When you precipitate out the sample, you get percent composition of the element that you're looking for in that precipitated sample, and then you relate it back to the original sample. Okay, so practice those. All right, so the next series of problems that we're going to do deal with solution stoichiometry, and then it'll take us right into titration. And titration is one of the most important things you can learn in a Gen Chem 1 class, because you use it in Gen Chem 2, you use it in organic, so it's a really important thing to know how to do, be able to calculate, and feel comfortable with. Before I get into a typical titration problem, I'll do a solution stoichiometry problem, meaning I'm having something with a solution, I'm using molarity, and I'm doing a balanced chemical equation, and that's the term stoichiometry. All right, so this problem here deals with this balanced chemical equation. Remember, stoichiometry always has to have a balanced chemical equation. So zinc sulfide, solid, will react with hydrochloric acid, 2 moles of hydrochloric acid, aqueous, to produce zinc chloride, aqueous, plus a gas, H2S gas. All right, and here's the question. How many milliliters of a 0.0512 molar HCl are required to react with 0.392 grams of zinc sulfide? All right, so back in chapter 3 with our stoichiometry problems, we just related grams of this substance to grams of this substance. But now we're relating volume of this substance to grams of this substance, okay? So it's a little different. This is why we call it solution stoichiometry, not typical reaction stoichiometry. All right, so never, ever start with molarity. Remember what I told you guys in the previous video? When you're given molarity, put units on it. So I've got 0.0512 moles of HCl per 1 liter of solution. Okay. Once you put units on it, leave it alone. Now go with the other thing that they're giving you. What information have they given you? They've given you 0.392 grams of zinc sulfide, and they want volume of HCl. All right, so we're going to start off with our zinc sulfide, because the only way we can start talking about HCl related to zinc sulfide is if we relate it through the coefficients of the balanced equation. 1 mole of zinc sulfide will react with 2 moles of HCl. It's the only way to relate the two, okay? So we've got grams of zinc sulfide. What do we have to do? We've got to convert that to moles of zinc sulfide. So we're going to write 0.392 grams of zinc sulfide. Okay, now obviously we need the molar mass of zinc sulfide, 1 mole of zinc sulfide. Stoichiometry is pretty much same old, you just keep doing the same stuff. Where's my periodic table? But again, it's so logical. It's not something I want you to memorize, it's just you have to understand the logic of it all. All right, so zinc is 38, gosh, I can barely see this, is a very, very tiny periodic table. 65.41. Okay, so 65.41 plus 32 is sulfur. 32.07 if we're going to go all the way here. Okay, 97.48. So 1 mole of zinc sulfide is 97.48 grams, all right? That'll convert your grams of zinc sulfide to moles. Then my next conversion factor will relate 1 mole of zinc sulfide to 2 moles of HCl. That's your molar ratio that we use using balanced chemical equations. So 1 mole of zinc sulfide will react with 2 moles of HCl. Good. So now we switched from zinc sulfide to HCl. Excellent. Now this is where it gets really cool. Remember that molarity that you guys created this thing over here? The 0.1512 moles of HCl per 1 liter. We're going to use this as a conversion factor to convert between moles and volume. But in order to cancel moles and end up with volume, you need to flip it. So we're going to put this down here, 0.0512 moles of HCl per 1 liter of solution. Okay, notice everything cancels now and you end up with volume of solution. So you converted your grams to moles, you use the molar ratio, these coefficients of the balanced chemical equation, molar ratio, and then you use molarity at the end to flip from moles to volume. Plug in the numbers, 0.392 divided by 97.48 times 2 divided by 0.0512. Press equals, and you will get 0.157, or if you switch it to milliliters, 157 milliliters. Okay, so that is a typical solution stoichiometry problem. In the next video, we will work on a bunch of different titration problems. Okay?